This is Geometry Unit 7, the Day 10 quiz number 2. We're finding the value of different segments that intersect a circle and also intersect each other. And there's a few theorems that we'll be depending on, and here they are. If they intersect in a circle, within the circle, this angle here, we'll call it angle 1. And you have this arc that's intercepted, and you also have this arc on the opposite side. So in this case, the measure of angle 1 equals half of the measure of those two arcs together. So this is when you only have, and again, they have to intersect within the circle, inside the circle, and the you don't have you have this arc and you have this arc. It's not necessarily a central angle, and that's the key here. Angle 1, this point is not necessarily in the center, so we have to use this arc here and this arc to find that. So it's going to be half of those two, half of the sum of the two arcs that those intercept. Okay, the next thing is what if they intersect outside the circle? So they have, for example, something like this, where you have, here's your angle, okay? You can find that angle if you know this arc measure and that arc measure. Okay, this one right here and this right here. If you know those two, you can find the angle. So measure of angle 1 equals 1/2 of the difference between the two. Alright, so it's 1/2 of the measure of arc X minus arc Y, and you take half of that and you get that angle. Another thing you're going to see is when you have segments that intersect in the circle, and let's call these this one A, that B, alright, this line here, and then this line we'll call it C and D. Alright, A times B will equal C times D, as long as their endpoints are on the circle and they intersect within the circle. The products of the two segments of each line within the circle are going to equal each other. Another thing you're going to see is when you have lines that intersect outside a circle. We're talking about just the segments here. We'll call that X and that W. Let's say from this point to this point is W. So W goes from there to there, and X goes from that circle endpoint right here to the other endpoint. Okay, and then we're going to call this one Z. It's the same way. Z is going to be from there to there, and then this is going to be Y right here, from there to there. All right. We also can define a relationship here. W plus X times W. So the sum of the two times the outside segment is going to equal the same for the other. So it's the sum of the two times the outside segment. Alright, so you're going to see that. Now sometimes the lines look like this. So we have, let's say a tangent. Let's just assume that's a tangent. You're going to have something like that where, let's say this is T right there from here to here. Alright, so we only have one measurement right there. And then we have, let's say, Z and Y. Well, since there is nothing else here to add, we could just assume it's like T plus 0 times T. And so we would get T squared. and then the rest is just the sum times the outside segment. And so you can solve it from there. As long as you have two of those, you can solve for the third. So let's look at number 1. Find the value of x if necessary around the answer to the nearest tenth. Okay, we have lines that intersect outside a circle. And we have, we're dealing with segments here, not angles. So that's x and 7 and then 18 and 9. Alright, so here we can use our theorem that if we add each segment of the same line, and then multiply it by its outside segment, then that should equal this one. It should equal the same thing on the other side. So it's 18 plus 9 times 9. Okay, and it's a little bit difficult to see. Let me kind of rewrite that for you. So you have 7 plus x times 7 equals 18 plus 9 times 9. So here you're going to distribute right there. And for this one, you can distribute first, or you can just add 18 plus 9 first. Either way you want to do it. So for this side right here, I get 7 times 7, which is 49. 7 times x is 7x, equals 18 plus 9 is 27, times 9 is 243. Now I can now just solve this equation. It's basically just algebra right now. So it's minus 49 from both sides. That cancels, and I get 7x equals 194. And x is about equal to, let's say we have to round to the nearest tenth, and it's 27.71. So I'll just put 27.7 as my answer. And that's the length of this side right there. Alright, number 2. Find the value of x if necessary around your answer to the nearest tenth. Okay, here we have more of what I showed you before with it's a segment, again, two segments that intersect outside the circle. We're going to try to find x, and we have 9 and 10 on the other one. So again, we're going to do the same thing, but remember, it's going to be the sum of the two parts times the outside part. And you know, in this one, you don't have any, you just have one measurement because it's actually tangent, it doesn't intersect the circle. So it's kind of like you know, doing this, x plus 0 times x. Okay, well, you're going to get x squared anyway. So when you see that something like that, just square that number. So we're just trying to find x squared. Okay, well, 10 plus 9 is 19. So I have 19 times 9 equals x squared. 19 times 9 is 171. So 171 equals x squared. And then to solve for that, you just get the square root of both sides. And the square root of 171 is about 13.08. So we have to round to the nearest tenth. So it's about 13.1. And for number 3, find the value of x. Oh, by the way, number 2 was a multiple choice, so the answer would be C in this case. 13.08 is fine. It says round your answer to the nearest tenth, but that's okay. The answer would be C. All right, number 3, find the value of x if necessary round your answer to the nearest tenth. So here we go. We have two segments that intersect within the circle. This one is 7, this one's 18, this one's x, and this is 8. So what is the theorem that's going to help us in this case where they intersect inside a circle? Is going to be the product of the two segments, and on each one is going to give us, are going to be equal to each other. Alright, so now you just have to solve the equation. So 8x equals 7 times 18, and it's going to be, you know, we're going to divide each side by 8, right? So I just, before multiplying, I'm just going to try to cancel some stuff out here. The 8 will cancel with the 18. That'll give me 9 and 4. So that's 9 times 7. That's a little easier to deal with, right? So 63 over 4, which is approximately 15.8, and that's my answer. Number 4, we have some segments here. Let me get a better drawing here. We have a chord, a secant, and a tangent to the circle. So here's my tangent. Let's just assume that's a tangent, all right? I got my chord here, and I have that. So chord, a secant. All right, this is my secant right here. This is my chord, and my tangent is right there. All right. So now that you have that, I'm going to take these arrows off. All right. And now I also have some values I could put, and I have 6 right there. I have x, this is 3, this is 13, and this is 20. So again, refer to your packet for a little more information here. Okay, now I can use some of my theorems here. I'm going to actually use 2 of my theorems because I need to get this length here, because if I get this length, then I could multiply it by 3 and set it equal to 6 times x, right? But I need to know this length here first. So that's the key. That's what I want to get first. So how long is this whole thing? All right, well, I do know how to do that because this is the tangent. Okay, so remember how it works. The whatever this whole length is, I'm just going to call it s for secant. All right, and so this whole length. And this length is 13, so I add 13 and then multiply it by 13. Make that a little clearer. And I'm going to set that equal to 20 squared. So it works like that. Now, once I get that whole side, this whole length right here, then I could just subtract 3 and I get that one right there. So then I could use that as the theorem I have. So I get 400 equals 13 times 13 is 169. So again, make sure you distribute correctly here. Sometimes it's just algebra mistakes can throw you off. All right, that's it. That should be an S right there. Okay, and then I can subtract 169 from both sides. So I get 231 equals 13s, and then I divide by 13. And that length, that part of the secant, which is actually, in this case, a chord, if I just take that segment, that chord is going to be 231 divided by 13, which is approximately 17.77, okay? Now, let me kind of make that a little better here. So that whole length is about 17.77. All right. Now, if I'm doing this on a calculator, I might just keep that number in the calculator because I have to subtract 3 to get this length, right? I want this here, and I have 3. So I know the whole length is 17.77, and so I want to get this one. All right, so it's 3 less than whatever that length is. So I get 14.77. Now that's my length, and now I am ready to solve this and get that one length because I have the total length. And now I have 3 of those measurements on those segments, and now I could just multiply them and solve. So it's 6 times x equals 3 times 14.77. And again, you could keep that number in the calculator's memory. It's just for accuracy. So I would end up getting x equals approximately 7.38, and that's my answer. Okay. Number 5. We're dealing with angles here. We know that, let's just put our points here, D, B, A, C, and E. All right. And we know that this arc is 60 right there, and this arc is 106, so we want the measure of this angle. And remember from our theorems that we gave, this angle is going to equal, angle A is going to equal half of the difference between the two arcs because they intersect outside the circle. So it's going to be 106 minus 60. So I just solve it. 1/2, and 106 minus 60 is 46. So half of 46 is 23. So my angle is 23 degrees. Number 6, find the value of x. Here they have intersecting circles inside, intersecting lines inside the circle. We have an arc there, 37, is arc AB, and then CD, arc CD is 41 degrees. So we want to find this angle here. And remember, it's going to be half of the sum of those two because they intersect inside the circle. So this time I'm going to add. So it's very important. If they intersect inside the circle, I add them. If they intersect outside the circle, I'm going to subtract them. So I get half of 41 plus 37, which I'm just going to add those two and get 78, and half of 78 is 39. So my angle is 39 degrees. Number 7, I want to find the diameter of a circle. I have, this is 28, and I also have, this is 10. So it says find the diameter of this circle. You have D, C, B, and this is the center, O, and A. Alright, I'm going to assume this line's tangent because I only have that one measurement. So it's going to be 28 squared, remember, equals 10 plus some number, right? The diameter is what I want here. It's this segment here is the diameter. And I remember I multiply it by the outside measurement, which is 10. Alright, now I could just solve it. So I have to distribute and square 28, so I get 784 equals 100 plus 10x, right? And then I could subtract 100 from both sides, and I get 684 equals 10x, and now it's pretty easy because I could divide both sides by 10, and basically I'm just moving the decimal over, and so I get 68.4, and that's the answer. Number 8, we have quadrilateral in there, right? D, A, C, B. This angle, they tell us, is 53. And what you got to remember is that if it's an inscribed angle like that, it's going to be half of the arc that it intercepts. So what's the measure of this whole arc? Well, it's 106 because you have to double 53. So that's 106. Now what do we want? We want measure of angle D. We want this. What is that angle right there? Okay. So angle D is going to be 1/2, because remember it's outside the circle. So it's the 1/2 of the differences between this arc, ABC, and arc arc AC. Alright, now we need to find this arc. Well, we know that 106 is from here to here, and a circle is how many degrees? 360, right? So if we know this part of the circle, then we can get the other side of it by subtracting from 360. So arc ABC equals 360 minus 106, which gives us 254. So this arc here is going to be 254 degrees. Now we can find angle D here because we have this arc is 106 and we have this arc which is 254. So it's going to be, we just plug in, we just substitute 254 for arc ABC, and AC, we're going to subtract these, right? Arc AC we know is 106, so we already have that. So it's a 1/2 of 254 minus 106. And so that's going to give us 148. And half of 148, or you could divide by 2, however you want to do it, is going to be 74. So that angle right there is 74 degrees. It's angle D. All right. Next, write the standard equation for the circle, center -2, 4, and radius equals 6. Okay, so remember the standard equation looks like this. All right, so when you get EH and K, it's a minus, so you got to think of it kind of as a reverse. So if the center is at -2, 4, you've got to actually substitute the -2 in there for H. So it's going to give you x plus 2 squared plus, and then the it's positive 4, so it's going to give you minus 4 because it's minus K. And then squared, and then r squared, the radius is supposed to be 6, so r squared is 36, right? If r is 6, r squared is 36. So we put 36 right there, and there's our equation of the circle. I'm going to go ahead and break this up into 2 parts here. So go ahead and go to the next video for the end of the quiz.